Bismillah. Okay, welcome back. This is more 3D trigonometry, video number 3 in the series. We look at question number 5. Here we have a square-based pyramid. So it says that V is vertically above the middle of the base, and they're using some basic measurements. Obviously, because it's a square in the bottom, every length will be 10. So that's 10, that's 10, that's 10, and that would be 10. Okay, and then it says here that V to C, now the slanted side here is 20. Right, we have to work out now AC. Okay, let's have a go. Now A to C, oh that's very nice. Okay, right, in our diagram, here we go. A to C is going to be the diagonal of the square base. Now you got 10 over here and 10 over here. Even though again this looks like an obtuse angle, it is actually only a right angle because it is the corner of the bottom square base. Okay, so you have 10 by 10 and you've got to work out the diagonal, which is AC here. Okay, now as we mentioned before, in the question involves right angle triangles, we've got to work out the hypotenuse. We've got to use Pythagoras theorem. Pythagoras theorem, a squared is equal to b squared plus c squared is one variation, where a is always the, in this format, in this variation here, a is always the hypotenuse. So the hypotenuse here is AC. Now b and c can be any of the two other values in any order. So we've got 10 squared, 10 squared. Now we want to work out AC and not AC squared. So for that reason we need to move the square sign over. The opposite of squaring AC is to square root the rest on the right hand side. Okay, now, so 10 squared will give you 100, another 10 squared will give you another 100, so we got to work out the root of 200. Okay folks, so in our calculator, okay, we're going to do the square root of 200.
10 root 2.
Okay, that gives you 10 root 2. Okay, and as I said before, I like to keep the root in the answer for the moment, especially when you start reusing these values into another part of the question. Okay, so we have AC is equal to 10 root 2. Right, that's the first part done. Next was to work out the height of the pyramid. Now, the height of the pyramid is the red line over here. Now don't forget, if it's going straight down, it will meet the bottom line AC at 90 degrees. So again, this part here will be 90. So if I redraw that triangle, so we have here V at the top, this is the height. Okay, and we have here, now this is A to C, this is half of AC. Okay, and we want to work out the height, and the slanting side is 20. Okay, now we have just worked out in the previous part, part A. In part A, we got AC. AC is 10 root 2. So half of AC would be half of 10 root 2, which will give you 5 root 2. So AC divided by 2 can be replaced by
5 root 2.
Can be replaced by.
So isn't it 5 root 1?
No.
5 root 2.
Okay, you don't half that and half that. I'll show you.
Or you just half the first number?
No, I'll show you what we've done. Okay, now what we have here, good question there, Ramiez. Why haven't we halved the 2 as well? When you cancel, we have a product on the top, 2 numbers multiplying, and you see what can I cancel? I can't cancel the 2. That's not a 2, that's a root 2.
Oh,
you can't cancel
those. You cancel the numbers instead.
You cancel these 2 here because they can. So these 2 here, in this diagonal here, 2 divided by 2 is 1, and 10 divided by 2 is 5.
Yeah,
you can't cancel a 2 with a root 2 because you can't. Okay? Root 2. So that'll give you 5 root 2. Well, that's a little side explanation and a good question by Ramiez. Okay. Now, if you look at this question over here, we've got a right angle triangle. We know the hypotenuse this time. We know the adjacent, the bottom, and we know the height here as well. Now what we need to do, we need to use the same formula for Pythagoras theorem. So let's start again with the same formula. Okay. So we have a squared is equal to b squared plus c squared, where a squared is the hypotenuse squared, which is 20 squared. B and C are the other two sides in any order you like. I'm going to call my HB, and the C will be the 5 root 2. Okay, so we've converted the Pythagoras theorem.
Do you have to rearrange?
You have to rearrange the equation and then work it out. So at the moment we want to make H the subject. So it's being currently squared, which is called our first action. Then it's being added by 5 root 2 squared, second action. We always move the second action first. So opposite of adding this part is?
Dividing.
Minus.
Oh yes, yes.
Okay, so we're going to have here 20 squared minus 5 root 2 whole squared is equal to h squared so far. Now we need to move the squared over. That goes over the brackets. So that goes over the equal sign. So that becomes 20 squared minus 5 root 2 all squared, and all of that square rooted will give you h. Right, quickly folks, can you work that out for me please?
Yeah.
What did I give you? So this
5
is
root 14.
okay, that gives us what?
5 root 14. Let's see if I did it right, because I did put the bracket things off. Like that.
Let me check. Okay, yeah, that was good. Ifra, can you try yours as well, please? Can you quickly have another double check that one? Now, remember, just as a quick, like a general rule of thumb, your hypotenuse is always the longest side. If by mistake you get one of the other lengths coming out to be bigger than the hypotenuse, then you've done something wrong. Go back, check through your calculations, and do it again. Right, what do you get, Ifra?
5 root 14.
Okay, lovely. Okay, can you press SD for that? What do you get?
18.7.
Okay. Right. So, question A and B have been done. We've done those. It was the angle between VC and the base. Angle between VC and the base. Okay. Now, if we look at this diagram back over here, the angle between VC and the base is this angle over here. Okay. Now this angle is the same angle over here. Okay. So in a sense what we can do, we can go back to part B of the question and we can now reuse that diagram and put in the angle that we need to work out. So we need to work out the angle C. Now, normally to work out the angle C, we're going to be using the right angle triangle, and we're going to use trigonometry. Okay, now at the moment we are in a privileged situation here that we know all three lengths. We know the height, we know the base, and we know the sloping side, the hypotenuse, 20 centimeters. But for the sake of argument, we're just going to use the two measurements we've already been given. So, I'm going to just quickly copy out that diagram again. Okay. Okay, now, okay, right, we need to label this right angle triangle so we can get ready for using trigonometry. Okay, right, opposite the angle that we're looking for, this is the angle. Opposite the angle, Ifra, is what? Opposite angle is called the opposite. Okay, and opposite the right angle, Ramiez, opposite the right angle is always the hypotenuse.
Oh, yes.
And the left over side is the adjacent.
Yeah.
Okay. So opposite the angle is the opposite. Opposite the right angle is the hypotenuse, and the leftover side is adjacent. So we put the adjacent in last. Now, what do we know?
So why is it called the adjacent? Why is it called like the leftover or the unknown?
Well, I think adjacent sounds better than leftover.
So it's ka.
Yeah. Now, that is the rule in its completeness. Okay, now we look at what we have. We have an ah sound. So we have the A and the H. So because we know the ah, so we look over here, where's the ah? The ah's in the cos. That's the quick way of doing it. Otherwise you've got to go back. If you look back at our video when we've done trigonometry,
The ah isn't in the cos, it's in the ka.
is it in the cos?
It isn't in the cos, it's in the ka, not the cos.
Oh, it is a cos.
Okay, that's the cos identity.
Yeah, it's a C,
Okay.
COS for cos.
Okay, right. If you want to see this method in more detail, please refer back to our lesson on trigonometry. Okay, now this is a quicker way of doing it. We know it's at A and a H. A and H is here. We know A. We know H, and we want to work out the angle. So the identity that we pick is the cos identity. Now, we know these two items, we don't know the angle, so we say cover the angle with your thumb, and that tells you the cos of the angle will be A divided by H. So cos of the angle is equal to A divided by H. Now, we don't want cos of the angle, we want just the angle itself. So we need to remove the cos, inverse the cos. Cos of the function opposite of cos is
Cos minus 1.
okay, just making sure that's all on there. Right, okay, let's put the values in, folks. Come on, let's get cracking. So you need to do now cos minus 1 is the adjacent, which is 5 root 2. Divided by,
So you know for
Okay.
the answer, do you want to do it towards 1 dp where you have to round up?
okay, give me your value for the moment. What's your value?
69.295.
69.295.
295.
So we're going to say, for our sake, okay, we're going to say, right, we're going to say that our angle rounded off to one decimal place is 69.3, because the next number is more than 5 or more. 69.3 degrees is our angle. So we're going to now just section this part off here as well. Okay, right. So far we've done 3 parts. We've worked out AC. We've worked out, after AC, we've worked out the height of the pyramid. Okay, from V to the bottom, which was the height over here. Then we worked out the angle that the slanted side makes to the base, which was the theta, the angle over here. Okay, we've done those 3 parts. Now, we've still got left here the angle AVB and angle ABC. Now, we need to clear off some of this stuff on the board, but we need to remind us how the values are. Okay, so A to C, let's write this down, folks. A to C is 10 root 2. Okay, and the height is?
The second one was
Height is
5 root 14.
5 root 14. And what was
And the third one was 69.2 degrees.
Okay, right. I don't think we need that one, I think. Right, let's put this stuff off because we're going to now need some more board space. Okay. Okay. Okay, bring it back. Right. Okay. That's all this. AVB. Okay, the angle AVB, which triangle? Now, if you look over here, right, the angle AVB is now looking at what? We're not looking at any of the dimensions apart from just that face. We're looking at this one face. Now, let's draw that face. At the moment, the face is leaning. Let's draw it as a two-dimensional image. So here's our A, here's our V, here's our B, and we've got to work out the angle AVB, which is this angle here. Okay? Which, according to our diagram here, is the angle between these two lines. Now, what do we know? Now, we know that due to the symmetry of the question, we have V to C is 20, which is the same as V to B. So these are also 20. So all the slanted sides are 20 due to symmetry of the shape. So this side is also 20. Now the bottom side is 10. Okay. Now we're going to work out the angle in the middle over there. Right. What we're going to do, we're going to relabel this diagram into our own diagram. So Ifra, are you with me? Okay. So I'm going to relabel it over here on the side. Now remember, we are now going to use, because we have all three lengths and we want to work out an angle over there, we are now going to use, again, we're going to use?
The cosine rule.
Cosine rule. Because we know all three lengths. Okay. But we just want to work out the angle. And the angle in the diagram is called A. So I'm going to relabel the V as A. And I'll call my A, the B as B. I'll call the side C. The red is the battle tiredness. It's a shame. Right, let's have a look. So we've got exactly the same diagram, the same angle, but we now relabel the triangle so it matches our formula. Okay, let's rearrange this formula. Right, Ramiez, quickly remind us how you rearrange it. So the opposite
Basically,
of add B squared is?
Minus B squared.
Opposite add C squared is?
Minus C squared.
So we have A squared minus B squared.
Minus C squared. And then minus 2BC is basically...
Opposite timesing?
Is dividing minus 2BC.
And then opposite of cos?
Is cos minus 1 equals A.
Okay. So that's what we got now, cos minus 1. Let's put the values in. So my little a is 10. So I'll label that as well for you, just so there's no confusion. That's little b. That's little c. Okay, big letter for capital letters for the angles, small for the side, which corresponds. B, little b. Big A, little a. These are the ones that we're interested in here. So we've got to work out the A, which corresponds to V in the original question, or AVB. Let's put the values in now, folks.
Yeah,
Okay, so we have here cos A squared. So we have 10 squared minus 20 squared minus 20 squared divided by minus 2 times by 20 times by 20. Close the brackets.
The answer is 28.9.
Right, hang on a second. Okay, so A is equal to, so look, if you got it as a third form as well?
No, this is like that.
You see that? 10 squared minus 20 squared minus 20 squared minus 20 times by 20 times by 20. Okay, that looks good. Right, that's 28 point, give me the 28.955 is it?
55024.
Okay, so the original number we got here is 28.955. If you round that off to one decimal place, okay, so we look at the next one, which is 5 more, add 1. So we get an
This
answer
is
of
29
29.0
degrees.
degrees to 1 dp. Okay, or 3 significant figures. Okay, so we got that A. We got one last part now, angle AVC. Okay, angle AVC, if you look at the diagram back of the diagram over here. Here's your A, here's your V, here's your C. So you're not just talking about one side of the diagram. Now you're literally intersecting, you're cutting the square base pyramid in half and two equal parts. So here's your A, there's your V, there's your C. So we're now looking at this bigger angle over here. Okay. Now, if we were to draw that diagram, and let's have a look at that diagram now. I will definitely need to rub off this space on the board.
So it's the same again like the 2D.
So I know you got space down there.
No, that's just what I mean. Let's get rid of this. So AVB is equal to that. Done.
Yeah, so you got space down there, it's alright.
I want to use more space. Okay, let's get rid of this. Right. So let's draw out the original diagram there. So there's my A, there's my V, there's my C. Now, remember before we worked out A to C? A to C is equal to what? 10 root 2, I think from part 1. Okay, so this length here is still 20, this is still 20. Plus 10, yeah, this one is 10 root 2, it's a different number altogether. Okay, right. Okay, ready? So, this question is similar to the one we've just done. We've got to work out this angle over here. Right. I'm going to quickly relabel the diagram. I'm going to call that big A, little a. Call this one here C, little c. Call this big B and little b. Okay. Alright, we have here, let's just hope we got some light back in that's the angle that we're looking for. Now, I'm not going to go through all the formula again. I'm going to cut right to the end part of the last part of the question that we've done. So what do we say, Ramiez? After we rearrange the cosine rule and we want to work out an angle, what do? We have to do cos to the minus 1 of what? A squared minus B squared minus C squared divided by minus 2BC, and that will give you your big A. Is that right?
Yeah.
That's the formula we used in the previous question. All of you doing is skipping a few steps. And because we know we've got to work at the angle, and we know the angles worked out by this variation of the cosine rule, we're just going to nick that from the previous question, put it into here, and get on with the question. So, our values, please, folks. Right, we have A squared. So we have 10 root 2 squared minus B squared is 20 squared minus 20 squared divided by minus 2 times by B and C, which is 20 times by 20, and all of that has to be cos to the minus 1, and that will give you A. So, right, that's the last part of that question. Question 5, part E.
The answer is
Answer to all of that is
421.40.
okay, let me just check the calculation on that. So you've got altogether 41.4096. So to one different place for 41.4.
So she got 41. I got 12 for 8.
Okay, in the last question, I don't know whether did I put the degree symbol in the last question? Have we done the video? Okay, folks, just make sure that in the last part D, if I haven't put degrees, it should be degrees. Okay, that's the end of today's session, folks, and end of video number 3. And inshallah, hopefully, we'll see you for some more questions on our YouTube homepage, which is Imran Iqbal One-to-One Tutor, the home of mathematics. See you till next time, inshallah. Assalamu alaikum.